everyone. This video is for the Chapter 3 supplement, Types of Statistical Studies and Study Design. So I'm going to kind of skim over most of this, but my expectation is that you read through it and work on the problems. And if you have any questions, you can ask in class. So one of the things this section talks about is statistical analysis. And remember that in statistics, it's very difficult for us to find parameters sometimes. Like, if we're looking for the average height of all males in the world, or if you're thinking about, what percentage of the United States citizens would vote for Joe Biden in the next election. It's impossible to figure those things out exactly because our population is so large. So what we do is we take samples and then we analyze those to learn about the bigger picture. And there's 4 steps to statistical analysis. And the first is that you should ask a question that can be answered by collecting data. So questions are great, but if you don't have the data to be able to analyze, you're not going to find out information about that. You want to next decide what to measure and then collect it. And as you're reading through these, you should be thinking of your term project. So far, we have done numbers 1 and 2 in the project. You've presented a question to me. We've narrowed down which one is good. You turned in your data to me, which was the most recent submission. And, from that data, you are measuring something. The next steps are going to be to summarize and analyze, and you're going to be using, the inference procedures we've been talking about, like hypothesis tests and confidence intervals. And then you're going to draw a conclusion and communicate your results. And you want to communicate them in a way that someone that is not taking statistics would understand. And that's very important to communicate your idea and your findings. So you can read through these different steps here. I'm going to summarize just some of them. So in statistics, when we're studying things, we usually ask one of the following types of questions. So we want to either research questions about a population, or sometimes we're even interested in researching questions about cause and effect relationships. And you have to be really careful when you determine that there's a cause and effect relationship, because that only occurs at specific times. There's a chart here that you can read through that kind of talks about, the type of research question and an example. Some of it we've covered, some of it we have not covered yet, but we will in this next half. So let's talk about cause and effect relationships between variables. Some examples could be like, does requiring students to do homework in college improve test grades? There's research about younger grades and homework, but what exactly is the research behind homework in college? Does caffeine reduce the risk of dementia? That would be great for me because I love drinking coffee. So to answer those questions, though, we want to investigate how one variable responds when another one is manipulated or changed. And the variable that we're changing is called the explanatory variable. So think of that as like your x. It even has the prefix ex in it. And the response variable would be your y variable. It's the output, and it's the variable that is measured based on the impact of the changes of the explanatory variable. And when we're interested in looking at explanatory variables and response variables, we are also interested in using an experiment that involves a change to the explanatory variable. So if you would like, you can pause the video, and there's a couple questions here that you've got to read through, and you've got to talk about the population of interest, the variables being studied, and the type of research question that is being asked. And then I'll go through each one. So, in the first question, the population of interest is the women who had visited the fertility clinic. The variable that we're examining for each subject in the study is whether they would choose the gender of their child if they were able to do so. So, that is what we are examining. And then the question that's being asked is, would less than half of women who visit the fertility clinic want to choose the gender of their future child? So the study is asking a question about a population. And we are going to come back to this problem, so please keep this one in mind. In the next problem, researchers wanted to know if students think that a task will be hard to accomplish when the instructions are difficult to read. So, they go through and they do two things with the instructions. The population of interest is the students. This is an experiment, okay, and we're going to talk about how we know that it is. The explanatory variable, remember, is what you're trying to modify or change, is the font type. So the font is what was being changed. And the response variable is what you're measuring. So what are we measuring? The number of minutes estimated to complete the task. The research question that we're asking is, will students think a task will be hard to accomplish when the instructions are difficult to read? The study asks a question about a cause and effect relationship. So something that's really important that I'm going to highlight here is whenever you are looking for a cause and effect relationship, the only way you can determine that is through a well-designed, controlled experiment. And that's worth noting right here. So I'll say that again because it's very important that the only way that you can determine a cause and effect relationship is through a well-designed, controlled experiment. So you need to have treatment groups. One of them needs to be a control group so that you can determine whether the treatment is working. So now we're in the second part of our statistical investigation, which is decide what to measure and then collect the data. So there's two types of studies used to collect data. You can either perform an observational study or you can perform an experiment. So in an observational study, researchers observe subjects in a sample to learn about population characteristics. So usually what will be involved in observational studies is you'll gather data either that's already there or data, you'll gather data over time for somebody. So there are two different kinds of observational studies. And this chapter really doesn't talk about those, so I'm not really going to mention them. But there are two different kinds of observational studies. So you can look at data from the past or you can follow data as it's unfolding. It's very important when you're doing an observational study that in order to learn about the population, you pick a sample that's representative. So like for instance, earlier I mentioned, what would be the height of males in the world, right? So a sample that would not be representative would be if I was to take the heights of all NBA players, because they're not representative of every single person that's in the world, right? They tend to be taller. So that would not give me a good representation, and I couldn't draw any conclusions from that. An experiment is actually where you are imposing a treatment onto something. So researchers actively manipulate or modify the explanatory variable. In that second example, the researchers changed the font of the instructions. So because they modified or changed something, this would be considered in an experiment. And in experiments, it's always important to think about what it is that's being imposed or modified. So the key difference between an observational study and an experiment is that a treatment is randomly assigned. In observational studies, we're not assigning any treatments. You can pause the video again, and then there's additional questions. This time, again, asking you the population of interest, the type of research question that's being asked, and the type of research study. So is it an observational study or is it an experiment? And what are the variables that are being studied? So really quickly, let's talk again about like population of interest. Like what exactly is the population of interest? It is just by name the population that we are interested in studying. In this first problem here, it talks about college having financial problems, and they're thinking about ways to save some money. So what they do is they are interested in learning about the proportion of students who would pay a $20 fee to keep the library open nights and weekends. So the population of interest, the population that I am interested in is the students that attend our college. I don't care about students that go to other colleges, just the ones that attend our college. The research question being asked is what proportion of students would pay the $20 fee to keep the library open nights and weekends? And the study asks a question about a population. So this is an observational study. The variable that's being studied is whether subjects would be willing to pay a $20 fee to keep the library open nights and weekends. So, think of this as what is being changed. Either you can agree that you would pay the $20 fee or you would not agree that that's a good idea. Suppose that we collect data by asking 100 students who are entering the library whether they would pay the fee. Would the sample be representative of all samples on campus? Why or why not? So I would say no. This would be convenient sampling. If you're asking 100 students who enter the library, it would also contain bias because students entering the library, they may be students who are, at the library all the time. So they might say, yeah, I don't mind paying the extra fee. But you have students who don't go to the library as often and they're still paying the fee, and they might not agree with that. Suppose we collect data by asking 100 students who we find hanging out in the school gym if they would pay the fee. Would this sample be representative? Again, I would say no, because those students may not ever go to the library. So why would they want to pay the $20 fee? They might not agree. But then you might have some students who do. But you're leaving out a portion of the population, the students that go to the library, that would have a vested interest in it. So again, it's important to obtain a sample of 100 students that's representative of all students at the college. Neither of those methods would achieve that outcome. So what do you think would be a better way to select the 100 students? If you said randomly, you are correct. And we've talked about the importance of random, in the past. In the next question, we're interested in learning whether jogging for longer amounts of time decreases the resting heart rate of college students. So in this question, they're dividing the students into different programs. So the population of interest here are the college students again. The question being asked is, does jogging for longer amounts of time decrease the resting heart rate of college students? So this is a question involving cause and effect, so it's an experiment. The explanatory variable, what is being changed, okay, so remember explanatory, I'll put here what is being changed or modified is the amount of time spent jogging, because one group is going to jog for 30 minutes and the other's jogging for 15. And the response variable, again, I'll write it right here, is what should be measurable. So what are you measuring? The resting heart rate. So if we were to create two groups for this study according to age, and we grouped the 50 youngest volunteers in the 30-minute jogging group and 50 oldest volunteers in the 15-minute jogging group, do you think that's a good idea? I would have to say no, because you're grouping by age. So people that are younger tend to be more physically fit, and people that are older tend to be not as physically fit as a younger person. Um, so when you're dividing the groups into, ages, like younger, you jog for 30 and older is 15, you get into variables that could confound what you're trying to measure. So they're kind of messing with the measurement and the experiment. So I would say that the age could affect the results. And we'll talk later on about a specific way to combat that, which is called blocking. So I would say no, because age could affect the results. And we would call age a confounding variable. So it's a variable that's having influence on the results, but it's doing it in an indirect way. So you don't know whether, okay, is it the age, or, is it the person that is jogging for 30 minutes or 15 minutes and their heart rate is decreasing or increasing or staying the same? What if instead we created two groups according to weight? Again, weight would be a confounding variable. Weight could affect the outcome. If you're heavier, you might have a harder time jogging for 30 minutes as opposed to someone who is more physically fit. So we need to divide the 100 volunteers in a fair way to be able to compare them. And again, if we were to do this randomly, we would combat any of the bias that would occur by separating people according to groups of those types, like age and weight. Next, we're going to talk about drawing conclusions from statistical studies. And when we make a conclusion, researchers are extending beyond the data that are observed to explain what they learned from the study. There's two types of conclusions you can get from a study. One of them is generalizing from a sample to the population, and the other is a cause and effect relationship. Both of these conclusions, though, are best figured out when you have random samples and random assignments to experimental groups. So when we're doing an observational study, we want to make sure we have a random sample to be able to generalize from the sample to the population. Typically, when you do experiments, a lot of times the people that are involved, the participants, it's not going to be random because people will self-select themselves to be a part of an experiment. And that's okay. The part that you want to be random is assigning the treatments. So in that last example, when we talked about, resting pulse rates decreasing after you jog, you might have 100 people volunteer to be a part of the experiment. Okay, and that's great, but they're volunteering, so that's not random. What you need to do then is randomize who is in each group, and then that'll get rid of the bias that could occur, as opposed to if we were to divide people up into groups according to age or groups according to weight. So it's the random assignment that's really important. The table summarizes when each of the types of conclusions is reasonable, so you can read through that. I am going to highlight some things here that are very important. So one of them is what I just talked about. Randomness comes from randomly assigning the volunteers to different experimental groups. so that we can make a cause and effect conclusion with volunteers, as long as the volunteers are randomly assigned to the experimental groups. If an experiment uses both random assignment and a random sample, even better, because then we can draw a cause and effect conclusion and we can apply it to a larger population. So we'll see more of these ideas in the next upcoming lessons. But without random samples in an observational study or a random assignment in an experiment, no conclusions can be reliably drawn. So I'm going to put a red flag right there. Make sure you understand and are aware of that. That's very important. What do we mean when we say a reasonable conclusion? It refers to the design of the study or experiment and whether the criteria have been met to reach the type of conclusion. So, in other words, considering the design of the study, is it appropriate to draw cause and effect conclusions? If it's an observational study, was the sample randomly chosen? If it's an experiment, were the subjects randomly assigned? So you can pause the video and try number 5 and 6 and then unpause when you're ready to go over it. In number 5, it says, recall the study of women who visit a fertility clinic. Considering the design of this study, is it reasonable to conclude that less than half of all women who visit the fertility clinic would choose the sex of their child? Explain why this is or is not a reasonable conclusion. I would say it's not, because you did not have a randomly chosen sample. Think about the study about font style and the amount of time the reader thinks the task will take to complete. Is it reasonable to conclude that a font which is more difficult to read will cause a reader to think the task described in the instructions will take longer? Explain why this is or is not a reasonable conclusion. For this one, I would say yes, because the researchers randomly divided the 20 student groups. And I believe, let's see, did they randomly assign the treatment? So it says researchers gave instructions to each group using 2 different fonts. They divided the 20 student volunteers into 2 groups of 10 students each. Researchers gave instructions to each group of students using different fonts. So it doesn't, the only problem I have with this is it doesn't specifically say that they randomly assigned the treatments, but they did randomly divide the students, volunteers, into 2 groups of 10 students each. So I would still go with yes. It is reasonable to conclude that a font which is more difficult to read will cause a reader to think the task described in the instructions will take longer. And then we have our summary here, which is very important to read. So please make sure you go over this. If you have any questions, please don't hesitate to ask me. And there is homework right after this, which is important for you to try. If you have any questions, please reach out to me.